Hello, welcome to my channel. We have been solving this commerce paper. So right now I have this paper 3, pure math 3, and it is from May-June 2025. We have already solved, I will 9 questions. You can check my uh, um, previous videos. So we will jump on to question number 10. Okay, so question number 10. Hmm, here we go, question 10. Okay, so question number 10, part A is very simple. Find the quotient and remainder when x square is divided by this thing. Okay, so what I will do, x square and divided by 1. If I write it 4x square plus 1, it should be okay, right? Instead of 1 plus 4x square, I write 4x square plus 1. Okay, so in order to divide, I have to multiply it 1 by 4. So it will become uh, x squared plus 1 by 4. When I do the subtraction, this will cancel. I left remainder is minus 1 by 4. So the quotient is 1 by 4 and remainder is minus 1 by 4. So basically x squared divided by 1 plus 4x squared can be written as 1 by 4 minus 1 by 4 divided by 1 plus 4x squared. Okay. I hope this is clear that when you divide it, this is how you'll get quotient and remainder. Okay, so part B, find the exact value of this integration. Okay, so let's integrate it by 4. Okay, so we have from 0 to 0 0.5 and x into tangent inverse 2x dx. So I will call this function as my first function and this one as second function. So first function into integral of second function, that's going to be x squared by 2, right? Okay, first function integral second function, and of course we have done the integral. I will do the limit 0 and 0 0.5 minus integral of the second function means x squared by 2 into derivative of the first function. Now remember, the derivative of d by dx of tangent inverse x is 1 over 1 plus x squared, right? So when I had to do the derivative of tangent inverse 2x, it is going to be 1 over 1 plus 2x squared means 4x squared into derivative of 2x, and that is going to be 2 into dx. And limits are from 0 to 0 0.5. Okay, I hope it's all clear. So this would be equal to, from here, you can see if I put upper limit, okay, the upper limit 2 into 1 by 2 is 1, the tangent inverse 1 is 45 degrees. It's pi by 4. And x squared is 0.5 and a half squared is 1 by 4 into 1 by 2, so this is going to be 1 by 8, right? Let's check. Yeah. Okay, and when I put a lower limit, it will become 0. It will become 0 because of x squared by 2, it will become 0. Okay, now minus here, you can see 2 cancels with 2, and I have integral 0 to 0 0.5, and I have only x squared over 1 plus 4x squared and dx, right? So this will become pi by 32 minus. Now here I will apply the results of part A. Remember x squared over 1 plus 4x squared was to this thing. So what I will do, minus integral 0 to 0 0.5, And here I will do 1 by 4 minus 1 by 4 divided by 1 plus 4x squared and into dx. Is it clear? I just substituted this part by the one I do in part B. Okay, so pi over 32 and minus, I can split it, integral 1 by 4 dx 0 to 0 0.5 and minus minus plus and 1 by 4 I can take it outside dx over 1 plus 4x squared 0 0.5. Okay, so now let me solve this part separately. 0 to 0 0.5 and dx over 1 plus 4x squared. Let me do some substitution. So 2x equal u, let's say. So 2 dx would be du. Okay, and what else? When x is 0, so u is also 0, and when x is 0.5, u would be 1. So this would be equal to integral from 0 to 1, and dx would be du by 2. Okay, and divided by 1 plus 4x squared is basically u squared. Right? 4x squared is u squared. Okay, so of course this is equal to 1 by 2, and this part is tangent inverse. So tangent inverse u, and it has limits from 0 to 1. 1 by 2, and when I put upper limit, tangent inverse 1 is pi by 4 minus 0, 0 is 0. So this is pi by a. Okay, so now this whole thing will become pi by 32 minus 1 by 4, and in integral of dx is x, and limits are from 0 to 1 by 2 and plus 1 by 4, and this whole thing is pi by a. Okay, I have these here, and I hope I'm not confusing you. Okay, pi by 32, and this is also pi by 32. So when we add them together, okay, look at separately, pi by 32 minus, what is this thing? It is 1 by 4, and when I put upper limit, it is 1 by 2 minus 0, so it is equal to 1 by 2 minus 0, and plus pi over 32. So this plus this will become pi by 16 and minus 1 over a. Okay, so the final answer is pi by 16 minus 1 by 8. I hope you understand every step and the logic behind every step. Okay, let's move on to question number 11. Okay, so we have given a curve which is given by this, which is represented by this expression, y is equal to 5 sine 2x into cos square x. Okay, and find the exact value of the coordinate of the upper end. We have to find the maximum value, so we have to find its coordinate, x coordinate and y coordinate. Since it is the maximum value, we can find its x coordinate by differentiating it and distributing it. Okay, so my first step is to y is equal to 5 into sine 2x into cos square x. So I'm going to find dy by dx. So let me consider this one as first function and this one as second function. So first function, which is 5 sine 2x into derivative of this part. So it is going to be 2 times cos x into derivative of cos x minus sin x. Okay, so first function into derivative of the second function plus second function, which is cos square x, into derivative of the first function. So it is 5, and sine 2x would be cos 2x into 2. Okay, I hope this is all clear. So I will write this first. So this will be 5 times 2 is 10, and cos square x into cos 2x. Okay, and this would be negative, and 5 times 2 is 10, and sin x into cos x, okay, into sin 2x. Am I right? I have included everything negative. I haven't considered 5 times 2 is 10 is considered. I have three terms, which is one is sin x, one is cos x, one is sin 2x. I have done everything. Okay, now I have to equate this expression to 0 and find the value of x. Okay, this sounds a bit complicated, but let's see. How can I approach this thing? I should take, okay, if I equate it to 0, right? So I can get rid of this 10 first, okay? So it is going to be cos square x into cos 2x minus, okay, no, I should not have. Let's divide by 5, or I should take 5 common and then divide everything. Okay, so I have 2 here. So I'm dividing by everything by 5. Okay, so this is 10 will become 2. Now 10 divided by 5 is 2. So 2 sine x cos x will become sine 2x. And again sine 2x, so it is sine 2x squared. Okay, and this is equal to 0. I'm trying to solve this part. Okay, what can I do now? Now 2 cos wait a second. If I take cos x common outside, okay. Okay, so let us not do this part. Okay, and I take 10 cos x common outside. 10 cos x. So what is inside? 10 cos x is gone. It is cos x into cos 2x minus 10 cos x is gone. So sine x into sine 2x. Okay, so I can equate cos x to 0 first of all. Okay, we will consider it later. So now I have cos x and cos 2x. I can split it as cos square x minus sine square x. Okay, cos x into this one minus, and this is sine x, and sine 2x is again 2 sine x into cos x equal to 0. Again, this would become cos x, rather cos cube x minus cos x into sine square x minus 2 sine square x into cos x. Okay, so, oh my goodness. Okay, yes. So this will become cos cube x minus, these two are same expression, right? 2 sine square cos and 1 sine square cos. So it will become minus 3 sine square x into cos x equal to 0. Okay, I can take another cos x outside. So it will become cos square x minus 3 sine square x equal to 0. Okay. If I start from the beginning part, it is going to be basically cos x. I didn't mention it, but there was a cos x everywhere. So actually, I have cos square x equal to 0. Okay. So from here, you can see that if I put cos square x equal to 0, it means cos x is 0. So x has to be pi by 2, right? So this is not a solution because we know it is over here. I mean, when x is pi by 2, the slope is becoming 0. Okay, so this is not I'm interested in. I'm interested in the other point where the slope is 0. So basically, I will equate cos square x minus 3 sine square x equal to 0. Okay, so from here you can see cos square x equal 3 sine square x. If I divide by sine square x, if I divide by cos square x, it will be 1 equal 3, and sine square or cos square is tangent square x. So tangent square x is equal to 1 over 3. So tangent x is equal to 1 over under root 3. And what is this angle now from here? X is equal to, if you remember, it is pi by 6. Okay, because pi by 6 is 30 degree. When angle is 30 degree, remember this is 1, this is 2, and this is under root 3. So tangent is sine, cosine tangent is 1 over 3 in the root. So 1 over 3 in the root is inverse tangent is 30 degree, which is pi by 6. So this is the result we got from this complicated equation. Now we were asked to find the coordinates of m, right? And the exact coordinate. So we need to find the y value now, right? So if x is equal to pi by 6, what is the value of this expression? Okay. So what was this expression? Okay, let me do it over here. It was y equal 5 sine x into, sorry, 5 sine 2x into cos square x. Okay. So 5 and sine of 2x, if x is pi by 6, means 30 degree, so 2x would be 60 degree. So sine of 60 degree, okay, and cosine of pi by 6, so this is cos square 30 degree, okay, so 5, 60 degree sines under root 3 by 2, and 30 degrees cosine is also 3 divided by 2, but it's square, so it's going to be 3 by 4. Okay, so when we try to simplify it, we become 15 under root 3 divided by 8. Okay, so the coordinates of point M, it is x is pi by 6 and y is 15 under root 3 by 8. Okay, I hope you understand every step and logic behind every step. Now the last is 11b. By using the substitution of this, find the area of the okay. So we have this curve, something like this. It starts from 0, goes to the maximum, and then come to 0. But this is pi by 2. We have to find the area from 0 to pi by 4. This is pi by 4. So we need to find this much area. Okay. So how can we do this one? What we will do, I have to integrate this expression 5 into sine 2x into cos square x dx, and I have to integrate from 0 to pi by 4. Okay, this is the integration I need to perform. Okay, so they are giving us a very good tool that substitute u equal to, make the substitution u equal to cos x. Okay, so what about du? It is going to be minus sine x into dx, right? Okay, so what else? Okay, so if x is 0, uh, yes, when x is 0, u will be equal to, what is the cosine of that? 1. And when x is pi by 4, u is going to be, when x is pi by 4, so 45 degree, cosine of 45 degree is 1 over under root 2. Okay, so my actual integration, it will become integration from 1 to 1 over under root 2. Okay, now we have 5 and sine 2x. Okay, remember sine 2x is equal to 2 sine x into cos x, right? So cos x is u, so it is going to be uh, cos x is u, so I have 2 u, okay, into sine x. Let me leave sine x in terms of x only, right? Okay, then I have cos square x. Cos square x is becoming u square x, right? And then lastly, I have dx, which is negative sine x into dx. Okay. Oh my God, what did I do? No. Dx, sorry. From here you can see that dx is equal to negative du over sine x, right? Okay, I made this mistake here. So basically when I have dx, so dx is basically minus du over sine x. So this sine x cancels with this sine x, okay? And I have 10, okay? And then u cube integral du, okay, that's it. I have, yeah, and I have this negative sign, and integration is from 1 to 1 over under root 3. Sorry, 1 over under 2. Okay, so this is minus 10, and it's u power 4 over 4. 1 to 1 over under 2. So when I put, I can take minus 10 over 4. And when I put the upper limit, 1 by 2 under root power 4, which is become 1 by 4. Am I right? Minus, when I put lower limit, it is 1. Okay, so it is negative 5 by 2. And inside I have 1 by 4 minus 1 is minus 3 by 4. So negative cancel, and that is 15 over 8. Okay, this is our final answer. Okay, I hope you understand every part of these two questions and the logic behind every step. If you ever have any question, you can always ask me in the comment section. And if you find these videos helpful, then please subscribe my channel. Thank you for watching. See you in the next video.